Ma'am, I think we can start the session.
Okay, ma'am. Sir, shall I start?
Yes, Dr. Dapati, you can start, or else it will be delayed.
Okay, sir. So, very warm welcome to all the dignitaries and dear participants. Today we are going to start the second technical session in day 2, and for the recapitulation of the event of yesterday, I would like to invite Dr. A.L. Haldar, sir. Sir, over to you.
Okay, thank you, Dr. Dapati. Now we have started the 3 days online training program since 7th of December. Yesterday it was there, and today is the second day. And yesterday, as per customary in the inaugural session, some keynote address was there, and that keynote address was given by Professor Chandan Ghosh from NIDM, National Institute of Disaster Management. He is an eminent professor. So during his speech, he said that flood mitigation and flexible storage system using geosynthetics. He highlighted that dams are very, very essential, which can control the water when incessant water is there, that can be stored, and as per need, it can be released for the benefit of the nation. And he told these synthetic structures, it can give a lot of relief, unlike other countries in India also. But of course, there are limitations in all the ways. But however, that it should be given importance for the synthetic structures. Thereafter, in the special address, Professor Binoy Pathak, we were fortunate, he was joined for the inaugural session. He talked some special address he has given. And the main point he has highlighted, that is the climate change. He told that climate change is the main phenomenon, main event that all the disasters are taking place. For that, he, as per his vision, as per his administration, as per his thinking as a academician, he told that deep research is required to control this, all this type of incident, this disaster incident. And after that, our second session, the first technical session started. There we had 2 speakers. That first speaker was from NRSC Hyderabad, Mr. Abhinav Sugla, who was scientist, AC from NRSC. He talked about the role of space technology in disaster management. Power of space technology is big support during any kind of disaster. He told where any kind of disaster, it may be man-made or it may be natural, that it has given a clue why it is happening and what is the devastation, how much it is there. Even in the interior place that public cannot reach, but remote sensing can guide you where to go and what is to be done. He talked in depth about the flooding. That is the depth of flooding also. That is the depth of flooding is very essential to calculate the damage. And also further, he said the duration of flooding that is there. And if you can study the duration of flood, you can get the impact of the damages. And a lot of things he said. And he has shown some case studies from UP, Bihar, and Gangetic Plain, and other, even Assam also, and all around he has shown his case studies for the flood management. Next speaker was from our NIDM side, Dr. Raju Thapa. So he has taken he says that groundwater quality management challenges and opportunities. He has given overview of groundwater pollution, exploitation in the country, and what is the causes of seriousness and happening vis-a-vis need of groundwater management. And a lot of examples, a lot of case studies he has highlighted. He explained the groundwater chemistry in India and threats of overexploitation and the need of societal role. So with this, yesterday it was end. Now today we'll be going to start for the second day session, where Dr. Dapdi told you that there are 4 lectures will be there. So all the eminent speakers are there. About that, Dr. Dapdi, our moderator, she will tell you. Okay, over to you, Dr. Dapdi.
Thank you very much, sir, for your kind words and recapitulation. Now, I would like to introduce Dr. Malay Pradhan, sir, and also going to invite him for his deliberation. That is, the topic is very interesting and very informative. The topic is legal framework of chemical disaster management. And he is a person, I just would like to introduce sir that presently he is serving as General Manager FNB in Odisha State Disaster Management Authority. He did his master's in heat power engineering from University of India and PhD on safety, health and environment from Sambalpur University. He has undertaken various industrial projects on socio-economic profile, carbon dioxide emission from thermal power stations, combustion of gas furnace, gas blended with coal, and monitoring of industrial equipment in various parts of Odisha. He has a number of publications on industrial safety, disaster management, and mechanical engineering in international journal and delivered various radio and TV talks in the same. He is also a PhD co-supervisor in NIT Meghalaya, SOA University, and KIT University of Bhubaneswar. With this vast experience of sir, I would like to invite Dr. Malay Pradhan sir, please share his valuable experience with our participant and obviously with us. Over to you, sir.
Good morning, everybody. Can you please give me to share my content?
Yes, sir, please go ahead. Presenter rights are already assigned to you.
Okay. Whether my slide is visible?
Yes, Dr. Pradhan, it is very much visible.
So, good morning, everybody. First of all, my heartfelt thanks to Dr. A.L. Haldar sir, who has given me the opportunity to speak in the program organized jointly along with CSJM University Kanpur UP. The topic that I am going to speak today is nothing but the legal framework on chemical disaster management. So let us first come to know what exactly a chemical disaster is. So chemical disaster is the unintentional release of one or more hazardous substances which could harm human health and the environment. So the point remain here is there is a release of a hazardous substance or hazardous gas in the process. So because of this, now let us come to the point that chemical accident. Chemical accident means an accident involving a fortuitous or sudden or unintended occurrence while handling any hazardous chemical resulting in continuous, intermittent, or repeated exposure to death or injury to any person or damage to any property, but doesn't include an accident by reason of only of war or by radioactivity. Now, the point remains here is, if we know that chemical accident is involved with sudden or unintended occurrence of handling any hazardous substance or hazardous chemicals. Now, what are the real acts that lies with that? How we can have an effective management on the hazardous or the chemical disasters? That is now the point of action. But prior to that, let us now come to know that where exactly there is a chance of chemical accident. So the chemical accidents can originate in the manufacturing or formulation facility in a factory where such chemicals are being manufactured. Now suppose in a factory where chlorine is manufactured or ammonia is manufactured. So in the process itself, and formulation means suppose one or two chemicals which are added and a new product is being made. It is the formulation facility. So in these areas, because of involvement of a chemical, now it may leak or it may cause fire or there may be overpressure and explosion can take place. In the process operation at any stage of the product cycle, now suppose a chemical is available, the chemical is required to be stored at a particular area, then it will be pumped through pipelines to the process, and there are various stages of operation. So at any point of time, there is chances of fire, there is chances of leakage of the chemicals, and it can also cause problem. And it can happen during material handling. Material handling, well inside the factory or outside the factory also. Once the material or the hazardous chemical is transported inside the factory, so it is lifted from one place to other place or stored somewhere. So during material handling and transportation and storage of HChem. Now suppose in a fertilizer factory, what happens? Suppose ammonia is the route from which the chemicals or the fertilizer is manufactured. Now the ammonia will be coming to the plant, maybe through ship, then from the ship it will be unloaded, and through pipeline it will go to the tanks inside the factory. Now these chemicals is transported through pipeline. Now during transportation also, suppose there is a leakage in the pipeline, it can also create problem. So the vulnerability is compounded due to location of the MAH, major accident hazard industry, closer to densely populated area. Major accident hazard industry means under the provision of Factories Act 1948, the factories are categorized as major accident hazard due to the availability of the chemicals having a threshold limit more than the permissible limit. So all these factories are classified as the major accident hazard factories. And such major accident hazard factories, if they are very close to the densely populated area, then the vulnerability of the incident or accidents will be more. That is what it means. Now, these chemical accident can come up in the shape of a fire, or it can be in the shape of an explosion because of overpressure. Suppose it is kept in a cylinder or in a vessel or in a tank due to overpressure, or maybe due to corrosion, etc. Now, due to overpressure, it may also explode. And there is a toxic release. Suppose this ammonia, chlorine, all these gases, styrene gases, methyl isocyanate, all these gases are toxic in nature. It means if a person will inhale it, then definitely it can lead to fatal. Then poisoning, like CO poisoning. Suppose a blast furnace gas is available in the plant. Now that blast furnace gas contains around 33% CO. So CO, once it goes inside our lungs, then it will come in contact with blood, and the affinity of the CO is more than 300 times than oxygen. So it will become CO poisoning, and you will not get oxygen, and it can also lead to fatal. And in some cases, combination of all the above, or maybe more than one incident. It may be fire and explosion together. It may be fire and toxic release together, like this. So these are the causative factors of a chemical accident. Now, such chemical accidents, now the effect can also be more or less depending on the wind speed. Suppose a fire is there and there is a wind speed is more. So the gravity or the intensity or the vulnerability will be more. The fire will expand very fast. And the direction, suppose the direction is the northeast, so definitely the fire will try to propagate in the northeast direction. So wind speed and direction will also affect the disaster capacity or the vulnerability. Rate of precipitation, toxicity or quantity of the chemical release, how much quantity of chemical that is released. Suppose during 2020, Sterling gas leaked in Vizag. Now, we must understand that at the particular point of release, how much quantity of chemical was stored inside the tank. But that is quite very, because you have to go for a dynamic record, otherwise it is very difficult to know, because everybody you can know by record, what is the tank capacity. But at the particular point of time or on the date of release, now what was the exact quantity of chemical available on the tank? Then what is the size of the hole? What is the pressure? How much time it released? So how much quantity of the chemical that came out in the process? And what is the wind speed? And what is the rate of precipitation? Then accordingly a dispersion modeling can be made, and we can know that this is the area and where the population, property, etc. will be under vulnerable conditions. Now the population in the reach of release, the probability for formation of the lethal mixture, and other industrial activities being performed in closer vicinity. There may be a cascading effect also. Now suppose more than one factories are close to each other in an industrial state. So what will happen? Now because of a chemical released from one plant, and suppose at the same time there is a fire in other plant, or because of the fire it may also lead to another fire in other plant. So there will be a cascading effect, and that should also be taken into consideration. And today the new concept actually that has come into the picture is that even a natural disaster can hamper emergency response to the technical accidents. So that is called NATE. So natural hazard triggered technological risk, which is very rarely considered in many places. One example is a tsunami triggered the worst nuclear disaster of Japan, popularly known as the Fukushima disaster that occurred on March 11, 2011. So all these things are there. Now, what is the concept of chemical disaster management? It is not only the concept of chemical, it is for disaster management also, one total. The earlier concept was reactive. So whenever there was a cyclone or earthquake or flood, etc., the Government of India or the respective state governments, they were going through a reactive concept that was 4R, that is rescue, recovery, relief, and rehabilitation. So it was understood that there will be a disaster like cyclone, and if the cyclone will strike, then we will rescue the people, we will recover the property, whatever damage lost, we will give relief to the people, and we will rehabilitate. That was the concept through which actually disaster management was aimed in. But after that, but now the present concept is a proactive. Even if a disaster will strike, if we plan well, definitely the damage will be less. So we have to rescue less people, we have to go for less recovery, we have to give less relief, we have to give less rehabilitation. So planning is very important. Suppose there will be a cyclone, if we can understand that that is the area through which the cyclone is going to pass, so we can simply evacuate people from that area. Or the latest technology is, now the cyclone will create damage. Now even the plantation of trees, now things are coming up, the trees that we are going to plant in these cyclone prone areas, now the roots will go deeper into the earth, whereas the height will be less, so that it will not be uprooted easily. The buildings that we are going to construct, it must withstand a wind speed of minimum 300 km/h, so that it will not damage. And depending on the wind direction, we will see that the net surface area will be less, so that the design, etc., if we can plan well, so definitely the impact of a disaster will be less. Then coming to the prevention, then preparedness and response, these are the new concepts. Now, coming to my topic, that is the legal framework on chemical disaster management. I am just not going very specifically on chemical. Suppose if you look into the Constitution of India, the Article 55A, Part 4A, it says it imposes fundamental duties on citizens of India. Some of these duties are relevant to the broad subject of disaster, and it says to protect and improve the natural environment, including forests, lakes, rivers, and wildlife, and to have compassion for living creatures, to safeguard public property, and to abjure violence. Thus, in true spirit, accident prevention and disaster management are also the fundamental duties of the citizens of India. That is the basic Constitution of India. It gives a direction that each society, all stakeholders, government, they must look into this aspect, and there comes the concept of disaster management. Now, coming to the chemical disaster management, the various acts, rules, etc., the major one is the Manufacture, Storage and Import of Hazardous Chemical Rules 1989, which is framed under the Environment Protection Act. And the salient features are this act has defined around 684 hazardous chemicals for which threshold quantity have been prescribed, beyond which they become hazardous. It indicates, if you suppose it is a matter of chlorine, if you have a capacity or storage capacity less than 10 ton in any factory, then we don't say it is a major accident hazard. If you are having at least 1 tonner, we can say it is hazardous. But beyond that, if it is less, so now it is. So the industries have been classified based on the hazardous chemical in 3 categories. Number 1 is the major accident hazard units. So coming to a particular chemical like chlorine, if you consider chlorine, if any industry where 10 ton or more chemical is being stored, handled, used at any point of time, then it is categorized as major accident hazard unit. Now, if it is 1 ton, even in a factory which is being used, we will treat it as a hazardous factory. Less than that, we don't consider it as hazardous, but even then, adequate precautions are required to be taken. This is what are the statutory provision of law. And depending on the nature and classification, now certain rules and regulations are required to be utilized there. Even these chemical accidents cannot take place particularly in an industry. It can be also in the hazardous installations. And these hazardous installations or isolated storages that has been certified or notified by the respective pollution control boards of the states. Whereas the hazardous, the chemical, the MH factory, etc., that is being notified by the chief inspector of factories of a respective state. Then notifying the site before commencement. This is also coming under this rule that we have to notify the site. Now, as it is understood that a chemical accident, the impact, the vulnerability will be more if it is well within an area where more and more populations are there. So, it is now mandatory under section 41A of Factories Act that we have to have a notification of sites. So, it says that before a premises is allowed to set up a chemical industry, we must understand what is the extent of damage it can cause to the locality, to the people nearby, because of a dispersion modeling. Suppose the ammonia plant, in a fertilizer plant, ammonia is being used, and dispersion modeling says that in case of a leakage, it can travel up to 5 kilometers. So, from the storage point, a radius of 5 kilometers, if you make a circle, then the people who are residing within that circle of having radius 5 kilometers are vulnerable. So, if within that circle more and more people are engaged or living, then the intensity or the hazard is still more. So, that's why it is always that the chemical industry should be away from the busy localities. Then preparing safety reports and updating after 3 years. Safety report, there are certain features. It also indicates that you have to go for a risk assessment study, that what is the hazard it will cause to the people, what is the hazard it will cause to the environment, and depending on what precautionary measures the industry has to take, and whether all the things are in line or not, the government, the public, they must know before it is being allowed to set up. Then conducting regular audits. Now, safety audit, that is what we want to say. There may be some other studies also, risk assessment study, hazard study, etc. for chemical industries. These are required to be done so that people can understand that yes, this is a chemical industry, the manufacturing process is this, the chemicals they use are these are the hazardous properties. In case of leakage, it can damage the environment like this. So once everything is known to the people and they are well educated what to do, then definitely it will be better, not only for the industry, not only for the government, but also for the people at large. Now, the preparation of on-site and off-site emergency plans. On-site emergency plan will be prepared by the management of the industry or the management of the isolated storage system. So, they will make the system that because of the leakage, in case of any leakage, what is the maximum problem it will cause, and what are the safety gadgets which are required, and whether we have kept it, whether we have got trained people or not, whether the people are well adequate with their gadgets or not, then how they will handle it. Then the the other acts are also the Chemical Weapons, the Convention Act 2000. Then the next act, that is the Chemical Accidents Emergency Planning, Preparedness and Response Rules, 1996. It is applicable to all chemical accidents regardless of scale, casualty. So this is also not only for the industry, it can happen even in even in a underground pipeline, storage, etc. So in a district, looking into all hazardous conditions. Now, in case of any chemical accident that I have already discussed, that wherever there is a chance of chemical accident, how they will immediately attend. Accordingly, the rules are the government must go for constitution of the CCG, Central Crisis Group, where the Chief Secretary, the Government of India, he will be the chairman. Then coming to the State Crisis Group, the Chief Secretary of the State, he will be the chairman. Then the DCG, that is the District Crisis Group, the collector of each district will be the chairman, and the local crisis group in a particular area where the cluster of industries are there. Then the sub collector, he will be the chairman of the group, and these meetings will be conducted regularly at the regular intervals, so that they will have a study in a particular area. What are the chemical industries? What are the threats? Whether they have taken all precautionary measures or not, whether they have gone for the safety audit, study, etc. or not, compliance is being made or not, on-site emergency plan is there or not, whether they are regularly conducting mock drills or not, is there any defects, whether the people are trained or not, the people in the vicinity of the industries, whether they have been aware about the hazards or not, and in case of emergency, what exactly they will do, then preparation of this safety report mock drill. There are also Ministry of Environment and Forest. There are many guidelines which also deals with the chemical accidents. A manual on emergency preparedness for chemical hazard 1992, a guide to safe road transport of HChem, hazardous chemicals 1995, a guide to the MSISC rules 1992, a guide to these rules on-site emergency, and guide to transportation of hazardous waste also. So these are certain things coming under the chemical accidents. The other acts and rules for the chemical accidents, that is the Indian Explosive Act, the authority is PESO, Petroleum and Explosive Organization. Then the Petroleum Act, then the Static and Mobile Pressure Vessels rules. The pressure vessels has been defined under various acts. Under the provisions of Factories Act, it says any vessels where a gas is stored above atmospheric pressure. But if it is if you are coming to a gas cylinder rules, then where the pressure is more than 2.5 kg per cm square. If you are coming to static and mobile pressure vessel rules, the volumetric capacity is more than 1000 liters, like this. And the ammonium nitrate rules, the petroleum rules, the gas cylinder rules, the calcium carbide rule, the Inflammable Substance Act, Bhopal Gas Leak Processing of Claims Act, and Public Liability Insurance Acts are examples of such legislation which provide resource to the victims. Public Liability Insurance Act 1991 is very important. It says, just like in Bhopal gas tragedy, what happened, because of the leakage, not only the people inside factory nobody was available, but when it went beyond the boundary of the factory, now the people in the vicinity were put to problem. So Public Liability Insurance Act will look into the area. We are having a good dispersion modeling, and from that, because of the availability of a chemical in case of a leakage, suppose it can travel up to 2 kilometers from the factory. Now we will make a circle having a radius of 2 kilometers, and we will try to find out the property, the people available in the locality, and we have to understand what is the net worth of that, and depending on that, the insurance has to be paid, premium has to be paid by the industries, so that even in case of a disaster, now the Insurance Act, that will Public Liability Insurance Act, it will take care of all the liabilities or compensation parts of the people. Now, other organizations who also discuss and deal with the chemical accidents are the National Disaster Management Guidelines for Chemical Disasters Industrial, that is framed by NIDM during 2007. National Disaster Management Guidelines for Management of Chemical Terrorism Disasters. The National Disaster Management Guideline for strengthening the safety and security the safety, strengthening safety and security for transportation of coal tankers, and chlorine safety by World Environment Center, code of practice for liquid ammonia storage, guidelines for safe warehousing of substances, major hazard control, a practical manual published by ILO 1988, then storage tanks for refrigerated liquefied gases with an outer concrete container. All these guidelines, etc., organizations, they are also in some way or other take care on the chemical disaster management. Now, there are some institutional framework. These are the institutes or agencies or the government system. They also look into the various aspects of the chemical accidents, like Ministry of Environment Forest enacting regulations. Under them, the Central Pollution Control Board, State Pollution Control Board, they are responsible to see that the central crisis group, state crisis group, etc. there. Then MOLE, Ministry of Labour and Employment, enacting regulation. Under them there is a DG Firstly, Director General Factory Advice Service and Labour Institute, and Inspector of Factories. Their job is to inspect the factory and to see that all such chemical accidents they perform or they run in the particular area with safety, so that the people well inside the factory or outside the factory are safe. Then MOS, RTS, Department of Road Transport, State Transport Department, Transport Commissioners, they are also responsible for this. They monitor the Petroleum Explosive Safety Organization, PESO. So like this, there are many organizations, they look into the chemical safety of the different industries. Then there are also many research institutes. They also look into the chemical safety or chemical disaster management. One of these are the institutes, Indian Institute of Chemical Technology, IICT Hyderabad, Industrial Toxicology Research Center, Lucknow, National Environmental Engineering Research Institute, Neri Nagpur, National Chemical Laboratory, Pune, National Institute of Occupational Health, NIOH, Ahmedabad. Then implementation agencies are DG Firstly, RLI, the Regional Labour Institutes, then state labor institutes. They also look into the issues, and there are some awareness and training. There are also agencies who conduct training programs and make the people aware well within the vicinity of the chemical industries. They are having autonomous bodies, they are having professional institutes, they are having private voluntary organizations and NGOs, even FICCI, even CII, all these things they are having. They are doing their job to constantly and continuously making people aware about the hazards due to this. And besides that, in international area also, the ILO Convention C-174 adopted on 22nd June 1993, dealing with the prevention of major industrial accidents involving hazardous substances. Then there are awareness and preparedness emergencies at the local level by Apple projects are there, United Nations International Strategy for Disaster Reduction. So all these things are also moving side by side, but we must try to understand what exactly their role are, how we'll get the benefit from that. In this, what I want to say is, now suppose there is a river, and on the river a bridge is there. Now suppose one LPG tanker, they are moving, and the first tanker met with an accident, and side by side there is another tanker, and parallelly very close to there is also railway line, and a train is also there. In the particular conditions, now a disaster will happen. So unless otherwise all stakeholders know about their responsibility, they know what are the rules and regulations, they are guided by this, definitely nothing is much going to happen. That's why it is very important that any point of time such accidents can take place. Now I can tell you that whenever there are any chemical accidents, the National Green Tribunal, they have given the verdict. It is ammonia gas leakage that took place maybe on January 2021. This is another on 18th of January 2021. Again, the Green Tribunal, they have given. The order says the proceedings have been initiated in the present matter based on media report with regard to the incident dated 22nd December 2020 about death of 2 officers and injury to 16 others in IFCO plant at UP on account of leakage of ammonia gas. According to the media report, the cause of accident was a technical default. This was the 3rd time that the ammonia gas leaked from the plant. So like this, all the things, even the National Green Tribunal, that take cognizance of the things and they give direction. You see, it is analyzed what is the cause of such a leakage of ammonia because of improper installation of the valve leading to reverse flow. There is operational negligence. There is lack of standard operating procedures. There is poor ventilation in the machinery room and non-issuance of personal protective equipment and failure to comply with safety practices. So if this is a lesson to us, we must learn from this mistake, and all other industries having involving chemicals, they must try to implement all the things. Although there are various acts and rules, it gives direction that all the things will be duly taken care of. But due to lack in the implementation, all these things do take place. So that NGC accepts the expert recommendation. Now, what is happening? Even if there are acts and rules, even if whatever the NGT has given the recommendation they have accepted, although these are well within the purview of one or other rule, but these were not duly taken care of. That's why rule alone cannot help prevention of a chemical accident. We must put into practice. Otherwise, things will not going to happen. So anyway, the NGT accepts the expert recommendation on gas leak incident, that is ventilation of the CO2 plant and machinery rooms, installation of check valve, relief valve, safety equipment, regular inspection. Regular inspection will not only be done by the statutory authorities, even the management of the factory, they are duty bound to go for regular inspections by their internal resources and try to comply things. It is not that someone outsider will come and point out, then we'll repair and we'll try to maintain. Avoid using galvanized component, employment of trained staff, unless otherwise the people are trained on chemicals, it is very difficult. Suppose that methyl isocyanate gas that leaked, even a wet handkerchief could have saved many lives, because the people are not aware of the thing, so nobody could use it. Then conduct of mock drills is very important. Not only conducting a mock drill is not enough. It must be well assessed and it must be documented. Whatever drawbacks are there, this must be put into paper and it should be circulated. And in the next mock drill, it should also be evaluated. Then and there will be improvement. So installation of gas sensor and alert system, that is very much important, because at any point of time wherever there is a leakage, if sensors are there, definitely it will be given a prior warning. So once the moment you get a warning very fast, definitely you will immediately attend. Provision of safety equipment to the staff, development of green belt. Development of a green belt is very important. If you look into the OISD rule, Oil India Industry Safety Standard Directorate, they say in all their petroleum products, installation, etc., they are having a core and buffer zone. So if you have to make 2 circles, in the inner circle, all core activities of the plant will continue. And in the buffer, that is the outer circle. So beyond the outer circle and beyond the inner circle, that is the area where your office room, where your parking place, and the green belt will be developed. So if you are having another plant very close to that, the adjacent plant will also having a core zone and buffer zone. So between 2 core activities of both the factories, now you are having 2 buffer zones of plant A and plant B. So that is the area that will act as a sink. So immediately the people, because of the leakage in factory A, the people of factory B will not suffer. So that is the concept of green belt, installation of firefighting equipment and conduct of public awareness. This is also under the statutory provision of law. If you look into the section 41B(4) of Factories Act, it says that it is the responsibility of the occupier of a factory to make people aware who are residing in the vicinity of the factory, what exactly is to be done. So considering all the things, now so what we will try to discuss is that a action plan is also required to be done. What is the action plan? A database. What is database? Suppose in the state, in a particular state, in UP suppose, if a question is put that what is the quantity of ammonia is being handled in a particular state, it should immediately give a result. So if there is a database, we can say that there are now suppose 120 organizations they are handling ammonia. And this is the number one is quantity is this, number two quantity is this. So that is the first step. Second is the dynamic database. At any point of time, suppose I now give the thing that today at this time, what is the chemical? So if dynamic means if the tank capacity is suppose 20 ton. Now at this present time, suppose now 16 ton is available. So we can give a dynamic data load also. So the capacity, the maximum, the inventory, the threshold, all everything, there should be a database of each district, of each state. Then only we can mitigate or we can have an effective disaster management on chemicals, whether conform to latest technology. Now you see technologies are changing. Now suppose in a power plant we are using chlorine. So chlorine is used. Now the substitute of chlorine is now sodium hypochlorite. Now chlorine is a hazardous gas. In case of leakage, definitely it can have fatality. But sodium hypochlorite, in the other hand, will not create much hazard. So a technology upgradation, etc., or latest technology. So this can also, in latest technology also, the safety parameters are inbuilt. So we must see that the old and obsolete technology, the industries who are having the old and obsolete, it should be updated. It should immediately, they must upgrade it with latest technology. Then material safety data sheets. Whatever chemicals are being used, a material safety data sheet must be available. And in the material safety data sheet, what are the safety precautions to be taken, what are the health hazards, and what precautions to be, everything is written. So wherever all these chemicals are being stored, the material safety data sheet must be displayed in a conspicuous place, and it should be understood by the majority of the workers employed therein. The SOP, safe operating procedure, safe maintenance procedure, the safety policies, safety committee, all this should be constituted. Safety committee in any factory where more than 250 people are working, and if it is a hazardous factory, irrespective of the number, so they must have a safety committee. Their job is they should have a meeting once in every month, and they will try to discuss with the people from the, because there will be a equal participation from management and workers. So the people who are really working with their chemical environment, they will definitely give the feedback. This is the thing, this is the thing, this is the thing, and definitely the best of the practices. The benchmarking will be made, and all sort of precautions to be taken. On-site emergency plan, off-site emergency plan. All on-site emergency chemical industry, they must prepare the on-site plan. It must be duly approved by the director of factory. Then they should go for mock drills. Each district should have off-site emergency plan. Preparation of state response plan from chemical disaster, that is also important. Not only for a district, even for the state, there should be a state response plan for chemical disaster. Then the SCG, state crisis group, this meeting should be conducted regularly. Crisis alert system should be there. Periodical mock drills, self-declaration of self-handling, and training and community awareness. These are certain action plans. Each and every district, each and every state, each and every organization, they must prepare so that it will improve. Now, there are some technical initiatives in installation. One is hazard analysis studies of industrial pockets. Now, suppose there are certain industrial states, and in the industrial states, suppose chemical industries are there. A project was made by Ministry of Environment and Forest. They were making this industrial pocket-wise hazard analysis. By that, in an industrial state, what is the hazard associated, because more and more industries are available. So considering all into one, they will now consider the vulnerability of that industrial state, and they will give a plan to government that these are to be done. Then GIS based emergency management system. So these things have already been taken place. Pilot study in Gujarat, Maharashtra, Tamil Nadu, it is done. Other states it should continue. Environment risk reporting and information system, emergency response centers and poison centers, and impact of chemical risk mapping. Risk mapping is very important. I have already told, depending on, there are many factors on which risk mapping depends. Number one, whether a tank having a hazardous chemical, whether it is above ground or whether it is on the ground, or whether it is underground, whether it is a rectangular or horizontal or a spherical. Where is the leak? What is the quantity of chemicals available? What is the wind direction? What is the temperature of the area? What is the whole size? What is the pressure inside it? What is the density? So a lot of things will come. Then dispersion modeling will be done. then we will go for a risk mapping. And now in a factory, suppose more than one chemical is there. Now it may so happen there will be a cascading effect. Suppose one chemical A, it can go up to a dispersion modeling says it can go up to 2 kilometers. Chemical B can also go up to 1 kilometer. And there is a factor that up to half kilometer, both A and B will be together. So that area is more vulnerable. So all the things, then other thing is a mutual aid response group, that is MARC. In each district, under the chairmanship of collector, these marks should be developed, so that now what is happening almost all over in India, the industry, they are having the mutual aid groups. One industry having a contract or agreement with 2-3 industries, and they are doing it. But mark is a concept, it can be done in a particular district, so that all hazardous units nearby, they can have together. Even it may so happen, suppose there are 2 districts, and in the boundary, suppose close to the boundary of one district, there is a chemical factory. Now it may so happen that in case of leakage of chemical from factory A, the chemical can enter into the district B because of the wind directions. So in that case, so the district B also keep in readiness in their offsite emergency plan because of the hazard in district A. That is very important. So district coordination is also very much important to handle this chemical accident because it doesn't understand the boundary. Then the redressal of the gaps in the statute, that is regulation of.
Sorry, excuse me. Sorry, Dr. Pradhan.
Yes,
so
sir.
could you please go for the conclusion?
Yes, sir. Yes, sir.
Please.
So now the redressal of the gaps, the penalized to the defaulter units, regulation to discard obsolete and unsafe technology, land use policy that I have told, all the things are required to be taken. So that's all. Thank you very much, sir. So you told that was my last slide also. Thank you, sir.
Okay, so nice. Thank you very much.
Yes, sir.
Thank you very much, sir. You have given a very good explanation about the chemical disaster. What is the chemical disaster? How this chemical disaster accident happened, with very extensive examples of various places. You also covered the act and rule which govern for the management of chemical disaster. So thank you very much, sir. Now I would like to invite
Thank you.
the second speaker, Sri Munish Ahmed, sir, Senior Geologist, GSI,
Hey,
Lucknow.
Dr. Dopudi, you please ask if any question is there or not.
Okay. Dear participants, is any question?
No, Dipali, please tell if any question is raised.
Okay, ma'am. Dipali, ma'am.
Yes, ma'am. So far, no
Any
question is
question in
there in
chat
the
box?
chat box, ma'am.
Okay.
So if in case anyone posts the question, we will forward it to sir. So far, no question is there.
Thank you. Okay.
Okay. Thank you, sir, and thank you, Dipali, ma'am. So now I would like to invite the second speaker of this day 2 technical session, Sri Munir Ahmed, sir, Senior Geologist, GSI, Lucknow, for his deliberation on review of Himalayan cryosphere in light of shifting climate problem and emerging challenges, a field-based approach. Before his deliberation, I would like to introduce about Munir, sir, that he is a geologist, as I already said. He completed his studies with gold medal and having lots of publication. Also, he is posting in various places of GSITI like Hyderabad, Lucknow, Jammu, Srinagar, and he is a senior geologist and also having FSP allocation projects on various topics like monitoring of glaciers of Ghagra Basin, Ladakh expedition, Hamtak expedition, seismic microzonation studies of Srinagar, and around 15 plus FSP allocation was there. So with this, I would like to invite Munir sir for his deliberation. Over to you, sir. I'm audible, sir? Sir, kindly unmute yourself.
Yes, Am I audible now?
Yes, sir. Yes, sir. You are audible, sir.
Is my screen visible?
Welcome, sir. Yes, sir. Your screen is also visible, sir.
Okay, so it's already afternoon. Good afternoon to the organizers of this training and the participants. As you already mentioned, that I have been working in the Himalayan cryosphere for quite some time now. So today we are going to review Himalayan cryosphere in light of shifting climate and problems and emerging challenges. We have a field-based approach in GSI. We do a lot of field work. So my deliberation, my topic will be mainly a field-based approach to this problem we have at our hand. So I would like to, at the outset, I would like to thank NIDM for giving me this opportunity for the second time to speak, to the participants, the young scientists who are, already doing some work in the Himalayas on the risk management and disaster management related to that. So a brief overview of Himalayan cryosphere. We are in India. We are fortunate that Indian Himalayas. I'm talking about the Indian Himalayas only here. Indian Himalayas has the highest concentration of glaciers outside polar regions. We have as many as 9,575 glaciers as per the 2009 inventory of Geological Survey of India. That covers an area of 37,579 kilometers. That's a vast area. That's why Himalaya is also called as third pole, because it has the highest concentration of glaciers outside the polar region. See, our 37% of our irrigated land is supported by these glaciers, fed by these glaciers, the meltwaters of these glaciers. So imagine a small change here and there. So that is going to affect the livelihoods of millions of people. I will give you a classic example. Imagine Ladakh without glaciers, where the precipitation is not more than 50 millimeter annually. Imagine a place like that. It's a cold desert where the annual precipitation is not more than 50 millimeters per year. So imagine a place like that without glaciers. Imagine the fate of and mighty Indus that flows through the region. Indus, the fate of Shyok that flows through region. Imagine the fate of those huge rivers without glaciers, with that precipitation I have already shown. So that is the importance of glaciers we have. So if we see, Geological Survey of India initiated the work on glaciers way back in 1840. We in India are lucky that we have been carrying out glacial studies right from 1840s. In 1874, it was Theobald, then Gangotri was sketched by Grisbech in 1889. That is the sketch on your screen. That was 1889 sketch we have. So we have a history. Geological Survey of India has carried out a lot of work on glaciers in Himalayas. In every part of Himalaya, we have carried out work in Eastern Himalaya, Central Himalaya, as well as Western Himalaya. So that is the figure on your screen that GSI has done so far. We have carried out repeat monitoring of glaciers in entire Himalaya region. You see the basin names are given there. You can see we have carried out in glacier research in Eastern Himalayas. We have carried out research on Central Himalayas. We are concentrating more on Western Himalayan part because of a lot of reasons there. So if you see this overall graph, this is the compilation of the entire work of Himalayan glaciers on your screen. So if you see here, in Shyok region, that is the Trans-Himalaya, that's the Karakoram part, you see the recession is very minimal.
Excuse me, sir.
And
sorry for interruption. Sir, slides are not moving,
yes.
Sir.
Okay, is it visible now, the graph?
Sir, yeah, it's visible, but it's not moving, sir.
No, I'm not moving it. I'm concentrating on this for a while. Is my mouse visible, the portion I'm trying to highlight?
No, Dr. Munir,
No,
it is
first
not
slide.
there.
We are able to see.
Only the first slide it is stuck up. It is in the first
Okay,
slide.
so
only.
now it's clear?
No, not at all. You please put it in this presentation mode, then and you please go to the appropriate slide.
Okay, so okay, just give me a minute.
Okay,
Okay,
no
sir.
problem.
Just wait for a minute. Give me a minute, please, because I will switch to some other network because probably the network is very slow here.
Okay, sir. Meanwhile, dear participants, if you are having any question, you may post in chat box.
So am I visible now?
Yes, sir.
Yes, it is.
Slides are visible.
Yes.
So where was the problem? Which slide should I start with?
Sir, first
Only-
slide.
Only it was in first slide. It was visible, not after that.
Okay. Only the first slide was visible.
Yes, sir.
Okay. I'm starting afresh. Sorry for the inconveniences. So I was talking about the overview of Himalayas, the overview of Himalayan cryosphere. In Indian Himalayas, we have 9,575 glaciers. That's a vast number of glaciers. And you see the area they cover. It's 37,579 square kilometers. That's a vast area. That's why we have the highest concentration of glaciers outside. We are lucky enough that in India, we have the highest concentration of glaciers outside polar region. And that's why Himalaya is also called as third pole. 37% of our irrigated lands are supported by these glacial meltwaters. So imagine a small change. Unfortunately, that change is negative because of the rising temperatures and climate change. So that negative change, if imagine a negative change happens, so what will happen to the millions of people that are dependent on the meltwaters of these glaciers, in particularly Indo-Gangetic plains. So imagine I will give you a classic example. Imagine a place like Ladakh without snow and ice, without glaciers. You imagine a Ladakh where the annual precipitation is not more than 50 millimeter per year. We have mighty Indus running through that region. We have mighty Shok running through that region. So imagine a place like that without glaciers. Geological Survey of India initiated this glacial work way back in 1840. So we have been carrying out the study of glaciers from 1840s. So in 1874, Theobald investigated some glaciers. Then Gangotri Glacier was sketched in 1889. That is the first sketch of Gangotri Glacier you see on your screen. That was sketched in 1889. So right from 1889, we have some sort of maps of some glaciers with us in Geological Survey of India. In 1906, 12 glaciers in Kumali Himalaya were mapped, and on 4th of January 1975, Glacier Division, which is at Lucknow right now, was established. So since then, we have been carrying out work on glaciers. So now this graph on your screen is the compilation of that work we have been carrying out. So you see few glaciers only there, but because we have been repeatedly monitoring them, our repeat cycle is after every 10 years, we make an attempt to map those glaciers again and then see the changes in the glacier snout fronts. So you see here, we have the glacier, we have studied glaciers in central Himalayas, we have seen glacier, we have mapped and carried out research in glaciers in eastern Himalayas and western Himalayas as well. Right now, our focus is on western Himalayan glaciers. And if you see this Shok area here, this Shok area, the glacier in Karakoram, these glaciers are receding, but receding very slowly compared to their counterparts in other parts of the Himalaya. And if you see this Indus Basin also, you see the glaciers are receding at a slower pace than the rest of the Himalayan glaciers. So if you see, there is only one glacier which show growth, positive. So that is this Tharakangri Glacier. I will talk about that. That is the Karakoram anomaly, because in Karakoram anomaly, we have glaciers advancing. We call them surges. We'll talk about that later. That rest of the glaciers you see, all are receding, all are negative. So all glaciers in Himalaya we have studied so far, except for one, are receding. So I will talk about in detail about Tharakangri Glacier, why it shows some advance. So at the outset, I'll give you, a model about what's happening in Himalaya. So you see, we have these receding glaciers. We have these receding glaciers in entire Himalayas. And what these receding glaciers do is that they have this recessional moraines which hold the water of the glacier and create an artificial lake. We call them proglacial lakes, or maybe a periglacial lake, or maybe a marginal lake, or maybe an ice dam lake. See, this ice is coming down stream and blocking the river and creating an ice dam and creating an artificial lake. So these are called ice dams. Then we have landslide, dammed lakes, and landslide happen in the river valley and dams the flow of the river. We have those type of lakes as well. We have rock dammed lakes as well. So this is the classic example of one of the glacial lakes that we studied in detail. Is called Gapangat Pro Glacial Lake. It's in Himachal. So you see here the clarity. This is a clear front of ice and water. So where this ice, this calves directly into the lake. So this is the huge Pro Glacial Lake, roughly 0.9 square kilometers in area. Roughly we can say 1 square kilometer area, pretty huge. I will give you an example here. Chorabari was 0.2 square kilometer only, and this is 1 square kilometer. Imagine if this glacier has, God forbid, if it bursts, imagine a level of damage it can do. So we studied in detail. In Geological Survey of India, what we did after Kedarnath disaster of 2013 is we created an inventory of glacial lakes to classify them, whether how many glaciers in Himalaya are critical, how are above critical, and how many of them are non-critical. So we created an NDWI mask. We in Geological Survey of India say that we believe that above 1 hectare area glacial lakes, they are dangerous. We evaluated them critically. We saw 3 parameters in dam. We created the dam type first. In dam type, we saw whether they are moraine dammed, whether they are ice dammed, whether there is a rock dam, whether there is a no dam. So for moraine dam and ice dam, they are critical. I'll see, in field we see whether, only in field we can see whether the glacier is ice dammed or moraine dammed, because usually satellite images don't show us ice cored moraines. When the dam is, when the moraine is ice dammed, it creates the level of danger increases, because ice can at any time it can melt and some seepages, then there will be some seepages, and through seepages that gap will widen and the entire volume of water lake will come out and create a disaster. If it is a moraine dam, the chances are there for breach. If there's a rock dam, there is no chance at all, and if there is no dam, then it's very good, because you see these 3 codes are given here: low, medium, and high. If there's a rock dam or no dam, then the chances of outburst susceptibility is very low. If it's medium, then there are medium chances, and if it's high, see ice dam and moraine dam is a bit intermediate between high and low, and for ice dams it's very high. So then we evaluated the other dam parameters that are given here, and we saw that picture in the entire Himalayas. These are the location, these are the coordinates of lakes in entire Himalaya right now. But they are not stagnant. This is not something that is going to stop. No, these lakes are expanding in volume. One category is falling in another category. For example, if some is uncritical, that uncritical lake is falling in the critical category, and critical category of lakes, when they expand in volume and size, they fall in very critical category. So nothing is static here. It's dynamic process. These lakes are evolving. The number is going to rise definitely. Their volume is going to rise definitely. Their area is going to rise definitely. Some of them will breach. So this is a continuous process in Himalaya that's happening because of the glacier recession. So when we see the entire picture from the Himalaya, from eastern, that's Arunachal Pradesh, we see eastern Himalaya in Sikkim also, then we see in Himachal, central Himalayas, in Uttarakhand also, then we see in JK, that's the western Himalaya. And when we see from east to west, there are glacial lakes present everywhere in every Himalayan state that has glaciers. So these red dots you are seeing is actually the location of the lakes that are very critical. See, these red dots, and orange dots are medium and yellow dots are low. So when we see this, we take an example of Sisu Glacier. That's what we studied in detail. You see, this is a Sisu River in Lahaul and Spiti district. This is the Lahaul and Spiti district. This is Himachal state boundary. This is the Lahaul and Spiti district, the largest district in Himachal Pradesh. So this is a Sisu village where this now the recently opened Atal tunnel opens up. This is the national highway from Manali to Leh Manali National Highway. So this Atal tunnel opens somewhere here. So there's a strategic importance of this road, because a lot of supplies come from Manali to Leh through this route. So tremendous importance of this area. So this is the proglacial lake of Gapangat Glacier, which we call as Sisu Lake as well. This is the Sisu stream and this is the Sisu village. These red dots are the houses. These green polygons are the agricultural land, some built up also there. So we'll see in next few slides. So these are the full field photographs of this Gapangat Glacier Lake, and you see the satellite photograph of satellite image of that. This is the proglacial lake. This is the Sisu village somewhere here. So we carried out combined study, both field and satellite based. We saw this Gapangat Glacier is increasing in size. Right from 1962, we had a 1962 topo sheet here, then 1973 image. If you see from 1962, 1973, 1976, 1999, 2003, 2011, and 2018, you see the progressive increase in the lake volume and lake area. So our study says that Gapangat Glacier receded 1248, roughly 1.2 kilometers in length. Imagine from 1971 to 2018, Gapangat Glacier had receded 1.2 kilometers. So that at an average rate of 24 meters per year. During our study, we saw Gapangat Glacier volume area has increased from 0.144 square kilometer in 1971 to 0.93 square kilometers. That's roughly 1 kilometer in 2018. You see these graphs from 1965 to 1976, the rate of recession was very less. It was less during the period from 1967 to 2003. Then suddenly from 2003 to 2011, the rate of recession increased, and it further increased in the period from 2011 to 2013. And you see, due to this recession, the lake has increased in volume and area progressively. This graph shows you that. So these actually, we have some triggers that actually induce this glacial lake outburst floods. We have a landslide that can induce this GLOF. We have avalanches that can induce a flood. Other large-scale ice break. We have all three present in Gapangat Glacier. A possible landslide zone, PLSZ, a possible avalanche starting zone. We have avalanche starting zones here. We have a possibility of large-scale ice break. We saw during the field this major chunk of ice got detached, and you can see them in the form of ice flows floating on the lake. We saw during our field work on that lake. So we created, we wanted to model this. If GLOF is going to happen, what will be its impact? So we modeled that impact. We created the geometry of the river, Sisu River, geometry of the lake. We know the volume of the lake that is stored in the lake. We know the volume of the water. We create land use land cover map also. So we saw that Gapangat right now in 2018, sorry, right now it will be more. We stores 31 million cubic meter of water. So that's an enormous amount of water. So if that amount of water is released at once, the peak discharge are going to be 32,000 cubic meter per second. So that's a huge amount of water flowing downstream. So what will that a huge amount of water do? That will create problems in the Sisu villages. These red dots are the houses and the commercial buildings in the Sisu village. I'll tell you that this infrastructure is increasing day by day. New houses are coming up, new commercial buildings are coming up, because I told you already this is strategic location. This is the link between Manali and Leh. So a lot of commercial buildings and a lot of projects are underway in this area, but this Gapangat Glacier poses a huge threat to this area. So what we did is we prepared a detailed report and sent it to NDMA, National Disaster Management Authority, and that NDMA gave that report to the civil authorities of Lahore and Spiti. They came with us to the lake. We showed them that we can artificially breach the lake so that we get the excess amount of water out of that lake so that the risk is minimized. We tried to explain everything to them, but I don't know what happened to that project. So far, that lake has not been breached. So I'll give a classic example of the recent happening in Himalayas. This is Rumbak village, which is in Leh. You can see the Leh town is somewhere here. It's the famous Peh village. A lot of people go for trekking to the Peh and Stock. This is the Stock village, and this is the famous Stock Kongri peak. In that area, there was a flash flood that happened on 21st of August. It was reported widely in the media, and the civil authority of Leh, I give them credit for this. They were swift in action, and they restored all the supplies of that Rumbak village despite that serious deluge in that area. So a lot of, fortunately, there was no loss of life in that area, because Rumbak village is just upstream of that area where this Glacier happened. So luckily there was no loss of life, and there was definitely loss of property, because 20 to 30 canals of farmland was washed away due to that Glacier event, which was earlier reported that only cloudburst had happened, but unfortunately it was a Glacier. So a lot of culverts, the road, 2 to 3 kilometers of road was washed away, bridges were washed away, communication lines were washed away, the power lines were washed away. A lot of damage in that area. I have personally been associated with the project, with this task. So earlier what happened in media, because media is quick these days, so they reported that it was a cloudburst event which created this deluge. But we see IMD data on 21st of August, only 0.3 millimeter of rain. So there was no chance of cloudburst in that area. It was purely misreported by media. Then the media and the civil administration they were very quick in action. They restored, like I said already, supplies of that area. Then if we see on the satellite images, we see this is the 20th August image of that lake above Rumbak village. So this is the 20th August image, and this is 22nd August image. You see the pre and post images. This lake was there, and this lake is no more there, because entire amount of water has got released due to that Glacier and washed away a lot of land in that area. You see that the extent of damage in that area. You see the over deepening in the upper channel, and then you see the lot of sediments were deposited in the lower parts of the valley, and you see the entire road that has been washed away. There is no road as such. We had to go hiking in that area to find out what has happened. So if you see now this Rumbak stream, what they did, it debauches into the Indus, and this is pre and this is the post image. You see the pre-event normal course, and then this sediment in the mouth. Am I audible?
Yes, sir, you are audible.
My slides are moving, smoothly.
Yes, sir. Till time it's okay.
Try to concise, Dr. Munir.
Yes, sir.
Sir, now you are not audible.
Oh. Am I audible now?
Yes, sir. But slides are not moving, sir.
No, I'm not moving my slide.
Okay, sir. Now okay. Sir, you are not audible, sir. Munir, sir.
Okay. So
Your voice is breaking, sir.
Just a minute. I'll change my connection again.
So still you are not audible.
Hello, am I?
Sir, your voice is breaking.
Yeah.
So you are not audible.
Am I audible now?
Sir, your voice is breaking. We are not clearly listening to you. We are not able to listen. So we are unable to hear you.
Am I audible now?
Sir, there might be the bandwidth issue. You can turn off the video and please continue if possible.
Yes.
Okay, sir, not an issue. Just yes. Your slide is moving, sir.
I'm stopping my video now and
Yes, sir, you are audible now. Okay, sir.
okay.
Yeah.
So I was talking about this area. So that this is the upstream. This is the upstream of Indus. You see the lot of amount of sediments were deposited here due to that Rumbak flood, and we see the water levels upstream of Indus are right now higher than the normal. Then we see what happened in Himalaya recently. On 7th of February, we had this Chamoli disaster as well. This is this red line. This red area is where the disaster started and flowed all across this, all along this red line, creating a lot of problems in the downstream. So we'll see to that. So if we see the pre and post images of that area, we see this on the 6th of Feb, there was a lot of snowfall in that area prior to that, and then this gap here, which you see on the screen, widened, creating a landslide. There was ice over that. There was this was a multi-hazard disaster, a classic example of that. If we see now, this is the area where the problem started. This entire area, including the ice, and then there was a landslide, rock slide, ice avalanche. Everything was there. So this entire area got detached from the main rock mass and traveled downstream, creating some damming first, and then entire this was washed downstream. So you see this detachment creek here. This is a new challenge in Himalaya right now, because everything can't be mapped using satellite images. We can't do field work also in that area because it's very tough and challenging. So we have to take care of these things. Now you see this Aronti peak, this rock slide, happened here and traveled all along this area, damaging Rishiganga hydropower project. Then this Tapovan barrage, up to Chamoli, this disaster happened. So the travel speed was very fast. The NRCA calculated that travel speed from the initiation to Chamoli, it was only 50 minutes. It took 50 minutes from its starting point to the downstream. So also you see there's a debate whether there was a damming of the river first and then this thing happened. Personally, I believe that yes, there was some damming first, because this is a aerial photograph. This was taken in the helicopter during our field work. We see clear damming signs in that area. So then you see the damage, what happened, because I'm moving through the slides quickly here. So then if we created, Geological Survey of India created a landslide hazard zonation map in that area. After this disaster happened on 7th of February, we created a landslide zonation map. You see roughly 61% of that area falls in that category of high landslide area. The probability of landslides in that area in pink color is very high. So these black dots you see in your screen are the active landslides right now. So already we know that these landslides, there are a lot of active landslides, and this is a landslide prone area. Still we went with those hydropower projects. So that is one thing we could avoid in future, because geological input to these projects is perhaps minimum. That's why these things are happening. Otherwise, if we see the active landslides, these black portion on your on the map, these are active landslides, and probability of landslide in the rest of the 61% of the area is very high. Still we went with this project. So that was the contribution after the February 7 disaster. Then if we see in Himalayas right now, the problem we have, we already have seen this Chorabari disaster that happened in 2013. So we know the possible causes of that, because see, this is one thing we have to take care of now in Himalayas, because we have a monsoon effect during summer. The westerlies were considered to be very weak during the summer months, but this is the classic example where we see even westerlies and monsoon, both combined effect of both created this Kedarnath disaster. You see how strong the westerlies were at that time. The problem is that we take global warming for granted, because what global warming has done, it has increased the amount of moisture in our two major weather systems, both in monsoons as well as in westerlies. So that is why during summer months also, the westerlies were strong enough to that was a combined effect of monsoon and westerlies that happened in Kedarnath disaster. Like I said in my earlier slides, the Chorabari lake is a marginal lake. So the area is only the area was only 0.2 square kilometer. That is 2 hectares only. Only the area was that much was the area. So created a lot of problems downstream. You see, the lake is here. This is the this marginal lake, only 0.2 square kilometers. So it got breached. That is the breach site where it got breached. So you see the damage. You see this was the lake somewhere here, got breached here. So see the damage it created. Such a small lake. So again, we have to focus on, while developing infrastructure downstream, we have to take care of these things in future. So I'm going to talk about another problem in Himalayas, that is the glacial surges and ice dams. So I'll give a classic example of Karakoram, what's happening in Karakoram. We know about Karakoram anomaly. I'm not going to give details of that, but we have surges. We have glacial surges in Karakoram. Globally, only about 1% of glaciers surge. Why they are surges? The surges are because of the glacier size. If the glacier size is huge, surges usually happen. Then the reservoir area, if it is large, glacial surges happen. Then slope also has an effect. Then temperature and the water supply at the base of the glacier. Then lithology also. Classic example of that lithology controlled surge is we studied Tharakangri in detail. We saw elsewhere in the valley, same valley, we have only one glacier that is surging, that is Tharakangri. Others are not, with the same amount of slope and everything is same, but the lithology variation is there. Tharakangri glacier is on marble, and other glaciers are on granite. So this is the classic Tharakangri glacier example. You see, this is the 2004 position of the snout. 2004 position of the snout is this. Just give me a minute. This is the 2004 position of the snout of Tharakangri glacier. So if I see it, this glacier, in 2014, this glacier has advanced this much. So we mapped it in 2018, and we see this has reached now to this point. From this point in 2004, this position to this position. So what that says is 501 meters of surge in 46 years. That is 192 meters in 10 years. That is 19.2 meters per year. So these surges, what they do is they block the main channel. We also see the weather data. I'm going to skip this because this is not important. So we see three glaciers actually, Chomkundam group of glacier in upper Shok region. They have same surge cycles. They surge, they block the main river, creates an ice dam, and then the flood downstream is horrible. We see a classic example of 1929 Shok flood. This was created by this surging Chomkundam group of glacier. Three glaciers mainly, Chomkundam glacier of central south are the most active, and they have dammed the Shok 13 times between 1826 to 1933, and they are going to dam the river again, and this is going to be catastrophic for downstreams. See, what happens is, this is a Chomkundam group of glaciers. They advance, they block the upper Shok river, which comes from the Rimu group of glaciers. They create an artificial dam. When the dam is no longer to sustain the amount of water that is stored behind the dam, they break and creates a flood. In whilst in 2018 fieldwork, we tried to, map those signatures of that flood, and we saw at Khalsar, they have written those flood lines, high flood lines. HFL is marked on the rock, rock faces, and this is the 1929 flood of Shok. So this is the Shok River. So we see from Shok River, the present level of river, the flood was 72 feet. That's 22 meters. So this was the HFL. This was on this rock face. This was the HFL. This is the present Shok. So imagine the intensity of the flood in that area. So we see these surges are happening again. You see this classic example where this glacier has surged, but the river has cut it down. That is luckily it has cut down. If it has not cut it down, then the dam could have again formed ice dam, and there could have been a possibility of flood. So right now we have to study things like these, because infrastructure downstream is increasing. See, we have to study these glaciers now very on a regular basis, because we have huge army bases at Khalsar, at Taizé, at Turtuk, and this is a Indo-Pak border here. So we have to study these surges on a regular basis. So thank you very much. So I hope after initial hiccups, I could complete my presentation well in time.
Thank you very much, sir, for a very elaborative talk on glacial lake outburst. You also covered the glacial recession, and you also talked about the surges and ice dams. Definitely, GSI is working in the field, so we can see this beautiful places and also what is happening in Indian Himalayas. So thank you very much, sir. And now I request to the participants, if any question you may ask, or you can write in chat box. Any question, please?
Yes, ma'am. A question is there. I have posted also. The question is how to identify potentially hazardous lakes.
So I have given you the detailed chart of that already. So I'll go to that. I have told you about the parameters, how to identify a potential lake. So if it's a moraine dam or ice dam lake, we have to take into our inventory. If the dam geometry, then if we see the dam geometry, width to height ratio is greater than less than 1 or less than 0.1 to 0.2, we have to take into consideration. If the width to crust ratio of the dam is less than 60 meter, we have to take it. Then if the slope downstreams is greater than 20 degree, we have to take it into consideration. Then we have to see freeboard as well. So with these parameters, all the parameters that we have taken into consideration, if everything is red or orange, that means it's a critical lake. We have to take into account the area, the volume, the freeboard, whether it's an ice dam or rock dam. When it's ice dam, it is highly dangerous because ice can't sustain that long. If it's a rock dam, then there's no problem. Then if it's a moraine dam, then we have to see, because moraines also, they are not very stable. Moraines are very unstable because they are not, very consolidated material. That's highly unconsolidated material. When the volume increases, area increases, these dams are bound to break. So this is the set of parameters we have taken into consideration. Once, after evaluating everything, we take them into 3 categories. That's uncritical, critical, and very critical. When it's very critical, we study in detail. Then we do the field work also. Like I said in my presentation already, that ice dam lakes are those, we can't identify them on remote sensing based data only. We have to go to into the field. We in Geological Survey of India now carry out GPR studies as well, because sometimes what happens, you are walking on a moraine, you can't see the ice beneath that moraine. So we are doing some ground penetrating radar studies as well to see whether there's ice present in those moraines or not. So simply I'm saying that this is a combined approach. We have to take both fieldwork and satellite data as well. So to see whether the lakes fall in critical category or uncritical category, or it's a medium critical.
Okay, sir. Thank you, sir. So one last question is there. Do ice dams always leak?
See, yes, depends on the river profile and other things. They do leak. They have some seepages as well, but majority, it's not when ice dam is created, that means the amount of inflow is greater than amount of outflow. That is when the dam will be created. Once that dam is created, there's a huge volume of water that is, behind that ice dam. So once the ice dam is very fragile, you know it because it's ice. It's not rock, it's ice only. So once that volume increases, the area of that lake increases, it creates a thrust. Once the thrust is created, or there is some secondary impulse as well. There can be secondary impulses, like I said. There can be avalanches in that area. There can be landslide or ice breaks. Those are the secondary impulses. Once those secondary impulses are created, they can also create a glow in that area. So they do leak. They are not leak proof, but the amount of inflow and amount of outflow, they are not in balance. That's why the dams are created. Once the dam is created, it bursts. Once it bursts, the large volume of water gets released and creates a deluge in the downstream area.
Okay, so thank you so much, sir. We are done with the question and answers, sir. Thank you so much.
Thank you very much. Thank you.
Thank you very much, sir.
Thank you.
Now I would like to invite Dr. A.L. Haldar, sir, consultant NIDM, for his lecture, Impact of Climate Change on Water and Agriculture. It's a proud privilege to me to introduce sir. Sir obtained post-graduation degree in exploration geophysics from Indian Institute of Technology, Kharagpur in 1985.
Yeah.
Completed PhD from Vikram University, Ujjain, MP. And after passing out from IIT Kharagpur, he served DAN's International Development Project, Government of Odisha, Bhubaneswar, as geophysicist. Thereafter, he joined Remote Sensing Application Center, UP Lucknow, as Scientist C and elevated up to Scientist G and worked on geophysical exploration for groundwater on hard rock area of Bundelkhand as well as alluvial area of entire UP. And 37 projects sponsored by state, central government and internationally also were completed during his tenure of RSEC UP. He was appointed as Director of Remote Sensing Application Center, Government of UP for a duration of 2 years and got superannuated in March 2020. Presently, he is working as consultant flood monitoring cell at NIDM, Ministry of Home Affairs, Delhi. And to the credit, he had 67 technical paper in international, national journal and symposium. And he visited France, Italy, Switzerland for technical program. So now I would like to invite our next speaker, sir, Dr. A.L. Haldar, sir. Sir, over to you.
Nice introduction. I hope my PPT is visible.
Yes, sir.
Yes. Okay, so nice of you. Good afternoon, everybody. And after me, that one more presenter is there. So I will not take, I have to cut that and I will not take much time about that. And already you have heard that climate change in Himalayan region, what is going to happening. That is basically in the region of ice country. But now I will talk what is happening in the plain area or the peninsular India. So you so in this I'll say for very few limited words about the COVID precautionary measure. So this is also part of our NIDM, that you should maintain the physical distance at least 2 meters and try to use the mask each and every time, whenever, especially whenever you will visit the crowded place, and after returning, and you have to maintain the regular washing of hand. And also whenever sneezing and other things will be there, or the tissue paper will be used, that will be collected in a very restricted place. And you have to self-monitor your health, as well as also you have to ensure the vaccination in proper time, that 2 vaccinations should be done. Now it is a huge topic, this climate change. Yesterday that Vice Chancellor told itself that climate change is the main phenomena for why all the disasters are taking place. Say flood, say drought, say even for this sometimes the chemical disasters are also happening due to the climate change also, and several calamities are due to the climate change. You know now that global temperature is increasing. Of course, it is very not in very dynamic mode, but it is moving in static mode. So in 20th century of last, and say middle or late, it is very, very visible, the climate changes phenomena, and it is activating increasing level of atmospheric carbon dioxide. That is the use of, that is the burning of the fossil fuels, methane gas, and other, even the stubble burning, that which is a common phenomenon in the northern part of India, that is also adding to some extent. But of course, it is a localized time, very limited time, but that will add the carbon dioxide in the atmosphere, and it will lead the climate change in slowly. The global warming driven by human-induced emission, what I told, and even also you should not forget that greenhouse gases, that is giving enormous impact to the climate change. But of course, climate change is a long-term alteration of temperature, and it is the typical pattern in place, causes largely in human activities. It is there, and the burning fossil fuels like natural gas, oil, coal, etc. These are activity a lot. This burning this material releases greenhouse gases into the Earth atmosphere and giving slowly impact to the environment, and different disasters are taking place. You know that several times different countries chief will be sitting in, and last in 2015 Paris Agreement was there. We are forecasting that during this 2100 year, that this global temperature may increase 2 degrees centigrade. Of course, in between 2 degrees, somewhat is increased, but they are kept aim that it should not enhance more than 1.5 degrees centigrade, because that is some calculation is there from after 2.5 degree centigrade. If it rise, a lot of devastation, a lot of things would not be controlled in different countries, say like India also. You know that due to the climate change in India, say out of 32 or 36 state as well as territorial ruled places are there, more than 26 are vulnerable. They are taking place, floods are taking place in this year also. This so by 2000, even last month also flood takes place in southern part of India. Delhi has recorded more than 1150 millimeter of rainfall. That is quite a history, and more than near about say 50 years record is there. And all these phenomena are due to the, what I will tell, this may be the impact of the global warming. Experts are already whatever they have forecasted, and it has taken place in not in Delhi, in other state of India. Now, India as well as other country, they are quite secure for food, and but paradox is that connectivity of large number of people, mainly in richer countries, they are overeating. As a result, long-term health issues is taking place. But on the other hand, some poor countries are there. They are having the lacking of this food. Now, the population again 2050 will increase, and definitely we should not face the problem for food, and we have to think on that. Now, the objective for the climate change, that is the impact of climate change on agriculture and water resources. It should be aware, we should be aware, and it need to make sure that enough food is accessible to everyone, everywhere, physically and economically, irrespective of climate change. Due to the climate change, definitely it will impact, and I will tell you one by one that what are the impacts will be coming for water resources and agriculture. And what I was telling that by 2050, the world population may increase. Whatever is present, at least 1/3 of that. So additional 2 billion people will live in 2050, and so we have to, another burden will be there, so we have to take care for that. The Food and Agriculture Organization estimates the production will have to increase by 60% by 2050. But how it is possible? All our limitations are there within that, and of course we have to enhance the productivity, and but we have to manage the thing that climate change should not enhance tremendously, and within that 1.5 degrees centigrade we have to manage. The goal is achievable provided by entire agriculture sector. We have to adapt the climate smart agriculture practices. The crops should be there which should be the climate smart. So climatic variables like temperature, radiation, precipitation, humidity, which are having direct impact on the productivity of agriculture, forestry, and fisheries also. Because due to these phenomena, the production will be less, so we have to take care. Now, and parallelly, we have to, the fossil fuel burning, we have to control. Like, unlike the stubble burning, we have to think on the fossil fuel burning also. This climatic and atmospheric condition that determines the vegetative growth, animal production. So naturally, we think on that how much we have to curb on the fossil fuel burning. You know that whenever emission is more, then changes in cool region in potential for increase in food production. Of course, in the cool region, it will absorb to some extent, but which are region like say Bundelkhand in UP or say Rajasthan area, how it is possible if the temperature is increasing. So we have to think on that, and we have to maintain the harmony. Due to the agriculture also, carbon dioxide releases, and it is, but of course, it is up taking care about the balanced way. That methane gas is increasing, obviously, but it needs the paddy field to this carbon dioxide also for their photosynthesis process. Of course, to somehow it is balancing, but whichever the more rice producing state, say Assam, West Bengal, Andhra, there that it has to maintain the release of methane gas, so that proper care should be taken for balancing the harmony. Now, whenever the temperature will rise, the glacier will be melting. Now you see the floral and fauna that in that region, that whenever glacier will melt, sea will rise, the flora, fauna, it will be distress to maintain. If there will be distressing, then definitely it will give the impact on the livelihood, and loss of ecosystem in the natural resource that is coupled with inappropriate changes, that is land use, are known as aggravating livelihood changes. You know, the socio-economic within the seashore or nearby area, a lot of persons are involved for the livelihood, they'll be distressing, and parallelly that they used to add the food product in our country also, so that will be stuck off. So livestock as well as forestry and fisheries, and which will be having impact for the people of India and joining. Now the direct effect definitely will be realizing the rising of maximum temperature side, parallelly minimum temperature size and sea level. Because the glacial melt will be there, what Dr. Munir was talking, the recession of glacier, and if the sea level is increasing and the nearby seashore and other area, it may impact, like if not flood, then at least some area will be submerged, like tsunami. Of course, it will be not that much in height, the flood, but some area it will be immersed, and day by day the shrinking glaciers are shrinking and retreating would be taking place, and surging glacier will be taking place in that. Now, the climate change, it has happened three events: that progressive climate change, extreme events, and threshold event. In the progressive climate change, what are the factors that will affect the food security and other impacts? That is loss of coastal habitat, increased rainfall variability, because due to this, this is the phenomena where the progressive climate change is there. It will be more vapor and more rain, which causing the flash flood in various cities and seashore area. And this increasing temperature in location lead more demand in water irrigation. Whenever temperature will be more, that it will demand the crop irrigation in time to time, and mitigation effort in input cost, reducing agricultural productivity. So these will be the mild phenomena, but it will be this progressive climate change, but it will impact in that region. But whenever the extreme events, that is the heat-related deaths, what is very common nowadays in India, say from the July month onwards, in Gangetic Plain as well as coastal belt, that heat-related deaths are there, and even during the summer season, that heat-related death is very, very common in Rajasthan, UP, and not especially northern part of India. And the deaths due to injury of flood, fire, all the things will be there. When the extreme event will be there, and the spread of pest. You have seen the locust has taken place. They are there in India last year. So this was the impact of the global warming, and the cultivable land, it will be reducing. Loss of water resources, which is common phenomena in hilly region, Rajasthan as well as Bundelkhand, is 3 or 2 years interval drought is there. And the heat-related stresses, it will reduce the production of cattle, mammal, other area, and increasing the death. But you think now the progressive event, extreme event, and after the extreme event, that will come the threshold events or tripling events. That epidemic will be spreading, crop failure will be quite common phenomena if the threshold events is there. Broad ecosystem collapses will be there. Economic crash due to systematic and multi-system spiraling effect. And due to that, people will be migrated. So a lot of inconvenience is there. Now in local level, what you have to do? Human migration from most affected areas, it will be affected in different regions because the livelihood will be reducing. Naturally, they have to take shelter for their income, and there will be stress for migrating from one place to other places. In extreme event, the wealthier person that will affected by population. Now in the progressive event, the middle class will be sufferer. Now whenever extreme event will be there, the rich man, they will be the sufferer. The stress on group will bring them to lower economic strata. Medium or longer term loss of productivity, assets will be the problematic. Now global resource require in new direction from basic services. Now in the threshold event, what will be the impact? Mass out migration due to that thing, and global economic consequences will take place due to the, so threshold event will be the most serious. Now we should not think, and we should be aware that the global warming, how it is giving the impact to the public. So accordingly, we have to, each and every individual should try to reduce the global warming. Now, if you see the water resources schema, then if the less participants due to this thing, this climate impact, somewhere it will be less precipitation and somewhere it will be more. So there will be a greater interannual variability. So wherever more rain, they will be wash out and lot of damage will be there. And in wherever less rain, snow melt, and due to the global temperature, snow melt will be there, and sooner spring, because the springtime, and since that time that snow melt will take place, the springtime will be the sooner will come, and glacier will be reduced, what Dr. Munir has talked a lot. Now, the increase in reliance on groundwater. So you have to defend the surface water will be reduced, then we have to depend on the groundwater. But for the groundwater, a lot of impact will be there due to that, because the pollution rate will be increasing, all the things will be there. So like that, so a lot of impact will be there in the water resources or cycle schema or hydrologic changes will be there. The potential change impact in water resources, there is more evaporation will take place. If more evaporation, you mean that whenever evaporation will be more, say for 0.5 degree centigrade rise, that you know the statistics almost 3% more increase in evaporation. So accumulation will be more. So what happening for the cloud burst? This is the one or other cause for the cloud burst. That is the more evaporation and more flood or more flash flood is taking place, because in a certain time or in a less span of time, a lot of rainfall will take place. And nowadays, you know, due to the urbanization, the flowing of water is not smooth and obstacle is there. So that's why the Chennai flood, Kerala flood, Delhi, Bombay, often and then in Kolkata, it is taking place. So this will be the serious thing. Now, it will increase the winter flooding also. So what happened that in that Uttarakhand area, that was February, at that time that flood takes place. Of course, that was that due to that experts are expecting that maybe that due to the glacial lake outburst. For that type of thing, the glacial lake outburst will be taking place if the incessant rain will be there. Now, why incessant rain? That is due to the increase in temperature, more evaporation it is there, and less snowpack will be there, obviously. If the summer will be more, snowpack will be less. Now, what Dr. Munir was telling, that 60% of in river, the water is coming due to the melting of glaciers. So that will be reducing. Now our big river, Holy River, Ganges, how they will survive. And a lot of places that even in the hill area, a lot of this hydroelectric power station there, then how they will survive. So these will be the impact. And similar risk will be increasing in aquatic ecosystem and fish
Haldar sir,
species. Yes.
sorry to interrupt, sir. Sir, we are shooting our time. Sir, please try to conclude this
Yes, yes,
session.
definitely. Within 2-3 minutes, I'll try to search it.
Okay, sir. Sure.
The climate change impact, it will water resources, what I told you one by one, but the carbon dioxide concentration in the atmosphere, it will be give a lot of risk, lot of problem, and lot of stakes due to the climate change or greater concentration of carbon dioxide. Now, what I told you, I'm not going to again. Now, on agriculture, what will be the impact? The climate change, it will warming that tends to reduce yield. What I was telling, that if the temperature is increasing, then the productivity or the production definitely will be less grain in the process, longer and warmer growing season, high temperature also interfere the variability of plants. Intense drought, what you see in the Rajasthan and some Bundelkhand areas, and it will be insects and disease will be increased. Now, that it is definitely think that you have to adapt in agriculture. You have to raise the irrigation efficiency, number one. You have to, the temperature resistant crop, you have to adopt this. We have to stop the stubble burning. Alternate process has to search, and already in Delhi government, they have taken place the stubble burning. So for agriculture adoption, you have to need, that is first. The second step that you have to improve the crop drought resistance crop, and you have to suitable the crop choices for that, and you have to rotate the crop also, which is better for the drought resistance. Select best crop for suitable land, and also you have to, as per the suitability of the land, you have to select the proper crop also. Raise ground in low areas and plant in shorter, but that you have to take the plant, you have to in rotation, that is for the also the short time that which can grow. Now you see in the flood region, the previous varieties in my left hand side, it is there. So you have to select the adaptable varieties, that is a more resistance in water, that is there. So like this, you have to take that up. And third thing, that during in the drought area, the previous varieties in the left side, now present varieties you have to select, so that at least some crop could be yield some say wheat, paddy, like that. That type of crop you have to select in the drought area. Now previous crop in changing atmosphere, that was here. Now you have to select other suitable new crop also, like this. In flooding area, so which is flooding area, so here this type of crop you have to change, and fish pond, some appropriate measure should be taken for livelihood. Now so wherever flood is more or some hill areas there, you have to convert in ecotourism. So, and also in flood zone area, you have to think on this type of mountainous zone, appropriate neighbor or appropriate environment you have to make. Now you know that due to the climate change, the soil, that it will lose their nutrient, and so accordingly it will be losing their fertility. So increasing temperature, it will give the greater impact, and low livestock productivity in high production cost, you have to think on that. The IPCC in the third assessment report, it has disclosed the impact of increased temperature and reduced precipitation resulting from climate change could lead to overall reduction in agricultural productivity and yields, including rangeland, livestock production, and threatening to food security in heightening the risk of famine. And definitely, if temperature will increase, that will give the illness in human and mammals in all categories. It will be there. Now you have to think on the resilient, climate resilient crops, what I was talking in my previous slide. And also you have to think the nutri cereals, say millets, this type of crop, you have to think on that for the further new cultivation. Now, how we can stop? Can we stop the climate change? Yes, we can think on that, and we can reduce the short-lived climate pollutants and can have immediate economic benefits from job creation and increased household income. Everything is having solution. So we have to act for the future, and we have to think on that for that. Then definitely we can work on somehow. So these are the things what you will do for climate change. So this is the things what we could learn. Now, for the interest of the society, for the need of the country, we should think, please assist to improving our approach for supporting sustainability initiatives and fill our quick interest and needs for the improvement of the environment. So thanks a lot for the patient hearing. Okay, now it is over to you, Dr. Yadav, please.
Thank you very much, sir. Thanks for a very good talk about the climate impact on agriculture. You covered very well the agriculture adaptations. What are the positive and negative impact? In fact, what we can do for climate resilient crop management, as you already told. So thank you very much, sir. Now it's 1:05, so I'll not take much time to start my yes, please.
Just a second. Before you start your presentation, please allow me to introduce yourself.
Okay.
So the last speaker of today's session is Dr. Draupadi Yadav. She's a faculty at School of Science at CSTM University, Kanpur. Her specialization involves environmental management, disaster management, remote sensing and GIS, natural resource management, pollution and biodiversity. And she was the topper of the batch of the MSc Environmental Science from CSSM University, Kanpur. She did PhD in Environmental Science from University of Lucknow. And her teaching experience includes from Department of Environmental Science and since 2016 till now. And she also had teaching experience at Department of Pharmacy Environmental Studies from January 2020. Her research experience includes a project scientist at Remote Sensing Application Center, UP, and a project fellow at University of Lucknow and project assistant at EMD IITR, CSIR Lucknow. She has various achievements and her contributions include as the CSJM University representative and team manager. And she did active participation as organizer, co-organizer, organizing committee member coordinator, event coordinator, faculty representative of environmental science in CSJM University, Kanpur. So with these words, I now invite you to please address our audience with your presentation. Over to you, ma'am.
Thank you. Thank you very much, ma'am. Ma'am, I'm not able to share my content.
Okay,
Okay.
just a minute. Now, ma'am,
Yeah, now it's share. Okay, okay.
okay. I think you have joined from two systems.
Yeah.
Okay, so I gave the presentation.
Actually, I was avoiding the technical glitch. That's why I
Okay.
just connected.
Okay, no issues, ma'am. Please go
Okay.
ahead.
Ma'am, slide is visible.
Yes, ma'am, it is visible, but I think there's some box coming there.
Okay.
It's a welcome slide.
Wait. Yeah. Okay. It's visible now?
Yes, ma'am. Please put on
Okay.
slideshow.
Now it's visible?
Yes, ma'am. Please go ahead.
Okay. Thank you very much. Before joining this session, I would like to thanks ED NIDM, Professor Surya Prakash sir, Dr. A.L. Haldar sir, and ma'am also for giving this wonderful opportunity to me to share my experience in this very important training program. Why I have put this welcome slide? Because now we are in the era where we are facing this problem. So that's why I have just welcoming everyone. If we will not take care of our environment, the situation would be same. Okay, my topic is societal role for environmental sustainability and disaster management. Everyone thinking that why capacity building for disaster risk reduction, and what is this? Whether we are responsible for society, whether we are responsible for environment, or we are connected with disaster, or what else? The student, the person, the layman, they don't know. They are just thinking, yeah, it's not our problem. It's a problem of somewhere else. But guys, we are the person who, if will not take care, definitely suffer problem. We know that we cannot stop the disaster to happen, but can certainly take some steps to reduce its adverse impact on the environment. And what is environment? We know that includes water, air, and land, and the interrelationship which exists among and between the water, air, and land, the human beings. We are the human beings and other living creatures, plant, microorganisms, etc. So we are living in the environment, and we are just thinking that the biological level of organization is different. We are different, environment is different, our responsibility roles are different. But friends, we can see this atom to molecule to macromolecule, cell to tissue to organ to system, and now it all from one level to another combined and form the biosphere. So we are in the biospheric zones. We are the population. If we'll not take care of the, our environment, definitely one by one step, our number would reduce. We know that we are having the biodiversity hotspot globally, but where we are, whether we are conserving this or not, friends, we have only one world. And do we want it like this or like this? It's on our hand. When man is unkind to nature, nature will not be kind to a man, because we are facing now the problem of climate change. As our previous speaker already told about the impact of the climate change, the global warming, we also face the melting of disasters, melting of glaciers, disasters, and rising of sea level, acid rain, loss of biodiversity, and pollution. We are just facing due to our anthropogenic activities. The issues, whether these are the issues, these are the environmental issues, or it's different from what we are doing or we are living. The protection and the conservation of our environment is our duty. Environmental issues being of international importance, because we know that disaster don't have the boundaries. We also know that air, it don't have the boundaries. All the natural resources we are just utilizing without taking care for their sustainability. So problem facing due to the development is also one of the major role. What we are just thinking that, yeah, we are the part of that development. So what we can do, whether we are also increasing the pollution. Now, the need for an alternative solution for energy and its need to save humanity from extinct and need of sustainable development. Friends, we know that as per the Brundtland Commission, our Common Future Report, the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So we have to think for the sustainable development. Whatever development we are doing, we have to take care for its sustainability. We know that we are having the sustainable development goal, and these goals, these 17 goals, especially the goal 6, clean water and sanitation, the affordable, this goal already talked about the affordable and clean energy. It's also talked about the industry, innovation and infrastructure. It's talked about the climate action. What our sir was already told, everybody is concerned about the climate action. What is happening? What is the impact? How we can reduce? So we are living in the environment. We have to think for the better environment, for sustainable environment, and for the sustainability. The environmental sustainability, what it means, actually the ecological integrity is maintained. All of the Earth's environmental system are kept in balance, while natural resources within them are consumed by human at a rate where they are able to replenish themselves. But what we are doing on the name of the development, we have to be very clear and crisp. That's why environmental education and disaster management education is not only knowledge, but need rapid action for the management. And our Indian Constitution already told, Article 48A, it's told that it's a duty of the state, it's the state shall endeavor to protect and improve the environment. And Article 51 AG is already told that it shall be a duty of every citizen of India to protect and improve the natural environment, including forest, lake, river, and wildlife, to have compassion for living creature. So we can't deny that it's not our duty. It's the duty of every one of us. Friends, we are having the environmental laws, rules, and policies. Now it's time to implement, to strictly implement all the environmental laws, rules, and policies, because without this, we can't reach up to that goal. So this environmental laws, rules, and policies we should strictly follow. And we are thinking, yes, can we reduce the disaster risk? Yes. The systematic process of using administrative directives, organization, and operational skills and capacities to implement strategies and policies, improve coping capacities in order to lessen the adverse impact of hazardous and possibility of disaster. Yes, we can manage the disaster risk. We can reduce the disaster risk. We know that in different segments, the different phases are in disaster management. We can contribute by ourselves in the preparedness part. We can also contribute in response part. We can also help in recovery and mitigative measures of different places. Why? Because India is uneven. Our earth system is uneven. So we can plan, and definitely government is doing their best duties. This nodal in India, the nodal agency for disaster management is already assigned. The flood disaster is taken care by the Ministry of Water Resources. Similarly, the cyclone, IMD is taking care of the cyclone. Earthquake, the IMD is already, and all other disaster is taken by the ministry. We know that the science and technology which saves life, money, time, and environment. So with using the technology, it's a time to use technology, and especially I am talking about the space technology. It's a time to use technology, as our previous speaker was talking about the glaciological inaccessible reason we can reach up to there, and also we can manage the disaster from far. So this technology we can use, and friends, definitely as per our requirement, we can prepare the thematic map and can help the society. As I told you, that Himalaya, our Earth system, this is the 3D satellite view of Himalaya, and we know that this our Earth, India is uneven also, this Earth system. So Himalayas, we are having the high-rise Himalayas to the coastal belt. So we are lucky that we are having the all type of climatic condition in our region. So we can plan, and in fact, in NIDM already having this data and helping the nation. And from starting, because the topic was also connected with the riverine plain. So from Rishikesh, this hilly terrain to, this is the picture of Rishikesh area, from hilly terrain to the plain, the Chhatrapati Sahooji Maharaj University, where I am sitting. This is the boundary of this university. We can monitor, we can easily monitor the disaster, what is happening, and how it would impact, for example, floods, heavy rainfall, urban floods. Every disaster we can monitor through this space technology. That's why this is the time of technology, and we are using, and we are lucky that ISRO is working well and providing the information. And so what we can do as we are from academia, we are from the academic institution. So it's our duty that just aware the people, improve the knowledge, attitude, and also skill enhancement is important. And this is the time of participation. So we need the community participation, society participation. So this innovation and entrepreneurship is also one of the part, because after the disaster, there are lots of problem and issues. So innovation, what we can innovate and how can we serve the nation, it's our duty. So think globally and act locally, because everyone can't reach everywhere. So it's our responsibility that think globally, that how can we serve the globe, but try to start from your own self, what you can do as a student, as participant, as public, as society. In this, we the university students are students, we try to participate, to work, and this is the actually picture of our student who is actively participating and trying to help the nation for awareness, for what they can do, and also they are skilling their own selves. So it's, we also know some people don't have enough fresh water where they live. It's important for everyone to conserve or save water so that there is enough for everyone. So we have to not only think for own self, but also we have to think for our friends, our colleagues, and others also. We believe that our beliefs are become our thoughts become our words become our action, and our action becomes our habit, our habits become our values, and our value which decides our success, happiness, and future. So we have to think for the sustainable future, and for doing or living the environmental sustainability, we maintain the environmental sustainability, we have to think for the eco-friendly practices. Just few eco-friendly practices wherever place you are, you just do, and help what you can do to maintain the eco-sustainability, and uh, uh, try to be help to the others. And it's like public transport, 3R, reduce, reuse, recycle, everyone know. Try to promote alternative energy resources, vertical garden and green roofs, eco mapping, monitoring and auditing, and promote public participation and ecotourism. And the very important and basic thing, what I think, that green psychology, green thinking and green habits, green laboratory, promote green university and green campuses, as we are living in the earth system. So we have to maintain this ecological balance. So this, let us work together for safer environment and durable and sustainable human settlement. This is our green campus of our university, and we just believe that work together. And for that, I am thankful to NIDM that they have conducted, they have given us chance to organize this program, to coordinate this program in our university first time. So it's a little change between change and chance. If you have a chance, try to change what you want. And thank you very much. With this word, I'm thankful to the NIDM, our Vice Chancellor, sir, Director, sir, who have given this opportunity to me, and especially Dr. Hazardous, sir, for his belief. Jai Hind. Thank you very much.
Thank you so much, ma'am, for describing so beautifully the relation of sustainability and disaster management, as both the domains are interrelated and are always connected in terms of substantive issues and of underlying research and policy changes. And rightly said, it's very important as capacity building is the only thing that is a central thing, I must say, to reduce the disaster risk, and we should come together locally, globally, therefore to fight together to such kind of the disasters. Thank you so much, ma'am, once again.
Thank you very much.
So, participants, now we have come to the end of our second day session of 3 days online training program. So, just a minute. Sorry for the background music. Actually, some construction work is going on at our office, so please ignore that thing. So now, as I was saying, that today we have come to the end of our second day of our training session. I request the participants to please join us again tomorrow at the same time with the same link, so that you can come ahead to listen the respective dignitaries of our third day session of 3 days online training program. And once again, I would like to mention those participants who have joined this session yesterday, today, and I request and I urge them to please join tomorrow also, so that you can be eligible for your certificates. Thank you so much. Stay positive, stay safe. Thank you everyone for joining.
Thank you,
all
ma'am.
the
Thank you,
speakers.
sir.
Thank
And
you all the
thank you,
panelists.
everyone.
Thank you participants. Thank you.